All right, let's see if we can finish this up here. So, the next problem that we're going to look at, if you'll notice here, this inscribed angle touches where the diameter touches, okay, or it intercepts this semicircle here, okay. So I went ahead and put that this is 180 degrees, and as we've talked, the inscribed angle is always half of that intercepted arc. You see how it comes in and meets there and there? So therefore, if this is 180, then this angle has to be 90 degrees right here, okay? So if I know that, then I know all three angles of the triangle, and I can set this equation up, right? The sum of all three angles is equal to 180, and then you can go about solving for x. So this leads us to theorem 9.8, which says this: an inscribed angle of a triangle intercepts the diameter or semicircle, I think it should be or semicircle, if and only if the angle is a right angle. Okay, so it intercepts the semicircle or the diameter if and only if this is a right angle. Okay, and vice versa. If this is a right angle, then we know that arc is going to be 180 degrees. Okay. All right, now on to our last one, and I put this as a heading, air test question. Why? Because I've seen this type of question multiple times, and it's a really, really simple question. Okay. And so here's what I want you to know. Let me get different colors here so we can see this. Okay. Now, if I look at angle V, this angle intercepts the arc here and here. Okay. And so if I go ahead and do that, right, I don't know, I know that this is 90 degrees, so as a result this arc has to be twice as much because the inscribed angle is half that intercepted arc. So I'm going to put that this is 180 degrees, okay? So if I go to the other side, and this arc right here, if this arc is 180, what does this arc have to be? It has to be 180 as well. So as a result, this angle is going to be 90 degrees right there. Okay. Now, for U and T, these two angles, U intercepts right here. Starts right there and goes all the way over here to S. So I'll put it out here like this. Okay. Now, I don't know what the measure of that arc is. Okay, I could put down 28x, but that doesn't help me out very much as far as the actual degree. If I take this same arc on the other side for T, okay, I know this is kind of confusing with all the different colors here, but again, I don't know what this is over here. I could put 16x plus 8, okay? Now, but what I do know is that this blue arc, I don't know if it shows up very well, but that blue arc goes all the way around the circle. Starts here, goes all the way around the circle. So that's 360 degrees. So if the inscribed angles have to be half as much as the intercepted arc, then this angle and this angle have to add up to 180 degrees. So I can go ahead and set up my equation like this and solve for x. Okay? And so the relationship that I really wanted you guys to see in doing this is this. I'll go ahead and solve for x here. This is going to be 22x. I'm going to subtract 4, 176. If I divide by 22, let's see here, is that 7, 8? Yeah, that's 8. Okay, so it's 8 degrees. If I plug it back in, 8 times 14, 80 and 32, so that'd be 112. Okay. 8 times 8 is 64, plus 4 is 68. Okay. Now if I add those two angles together, what does that equal? Equals 180. If I add these two angles together, what does that equal? 90 plus 90. That also equals 180. So what are we trying to see here? And I didn't put this in initially, okay, and so I want you to do that for me. Theorem 9.9 down here says this. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary, okay? So again, I want to really stress that because there's some easy questions on the air test if you can remember that. The opposite angles of an inscribed quadrilateral have to be supplementary, okay? So you see the homework problems there at the bottom of the paper. Thanks for being patient with me with this video, and hopefully I'll be back tomorrow. We'll see you. Bye.